Hello and welcome to the Nelson Math Focus 6 podcast. I'm Mr. Burko from St. John Fine Arts School, and this is Chapter 10, Lesson 2, Theoretical Probability. Theoretical probability is the other term that you need to understand in this unit. We learned about experimental probability in the last lesson, and our goal this time is to determine theoretical probabilities of outcomes and events. We have an example in our book on page 328. Jason's made 10 sock puppets for his sister's birthday party, and each guest at the party will choose a sock puppet from the bag without looking. There's a 3-step process here. Take one sock puppet from the bag without looking. Step 2, record the color of the puppet, then put the puppet back in the bag. Step 3, repeat steps 1 and 2 many times. So Jason's going to use the results to calculate the experimental probability of choosing each color of sock puppet. But first, we're going to calculate the theoretical probability. And what that means is we're going to try and guess with our best guess with using the information that we know, what are the chances that we're going to pull out each color of sock puppet. I don't have sock puppet pictures, so I used triangles here, but I use the same colors of triangles as there are in the book for the sock puppets. So the question for our page here is, what is the probability of choosing each color of sock puppet? Well, Ole is the person who evaluates Jason's experiment, and he says there's 10 possible outcomes. That means there's 10 possible things that could happen in this experiment. Each outcome is equally likely, which means that it's just as likely that we would choose this yellow one as it is that we would choose this gray one or this blue one or this green one. Now, there's obviously more yellow colored sock puppets and there's more blue colored sock puppets than any of the other colors. And we're going to talk more about that a little bit later. 4 out of the 10 sock puppets are yellow, and so that means 4 over 10 is our fraction, and the theoretical probability of picking a yellow sock puppet from the bag is 4 over 10, or 0.4, that's the decimal, or 4 to 10, that's our ratio. So it's not more likely that we would pick this yellow sock puppet, it's more likely that we would get a sock puppet that is yellow. Question A asks us, how do you know that there are 10 outcomes in Jason's experiment? Well, we know that there are 10 outcomes in Jason's experiment because there are 10 sock puppets, and so there's 10 things that we can pull out of the bag, and each one has a chance of being pulled out. Question B is, why are all outcomes equally likely? Each outcome is equally likely because you can put your hand in the bag and you could pull out any one. For example, if you reach in there without looking, there's just as much chance that any one of those could be in there if you've put them in the bag, and if you've shuffled them around or shook them up, then you don't know which one's on the top, so you don't know which one you're going to get. Question C says, theoretical probabilities can have a value from 0 to 1. 0 means that there's no chance. 1 means that there is a certainty of it happening. Why is the probability of picking a sock puppet with button eyes equal to 1? Well, in order to answer this one properly, I probably should have mentioned that each sock puppet has eyes, and they are button eyes. So if every single one has button eyes, then the chances of you choosing one with button eyes is 1. It means that it's going to happen. You don't have any choice because they all have button eyes. Question D asks, why is the probability of picking a sock puppet without button eyes equal to 0? Well, the answer is, of course it's not equal. Of course it's equal to 0 because there's no way you're not going to get one with button eyes. They all have button eyes. Question E says, what is the theoretical probability of picking each color of sock puppet? And we can figure this out by shuffling them around. We know there's 4 yellow ones, so we've picked 4, and that's 4 out of 10. We know there's 2 blue ones, so 2 out of 10. We know that there's 1 of each of these colors, so they're 1 out of 10. Thanks for joining me. That's the end of our lesson for today. Chapter 10, Lesson 2, Theoretical Probability.